For years, the electric vehicle industry has been trapped in a bizarre arms race. To solve range anxiety, engineers keep doing one thing: cramming larger, heavier battery packs into their cars until the suspensions buckle under the weight. But that extra mass creates a cascade of new problems. A heavier car requires more electricity just to move. It shreds through tires much faster. And when that massive battery runs low, you're stuck waiting at a charger forever. Automakers spent billions chasing 1,000 miles of range as the ultimate goal. They assumed that if you just build a big enough battery, drivers will stop worrying. But that ignores how people actually behave. We don't gauge our travel by absolute distance. We measure it in time. Being able to replenish your energy quickly is far more valuable than carrying an enormous, heavy reservoir of it everywhere you go. That is exactly the logic driving the newest technology from the world's largest battery maker, CATL. They realize that matching the speed of a traditional gas pump completely rewrites the engineering rulebook. By achieving true time parity with fossil fuels, we can stop treating the car as a heavy storage container. It breaks the cycle of bloated design and opens up an entirely new way to build vehicles. This chart plots the Shenxing cell's capacity. With lower internal resistance, the curve is nearly vertical, 10 to 35. Instead of relying on slow external heating elements, CATL engineers designed the battery to rapidly pulse electricity through itself. It warms up from the inside out, shedding the cold in minutes. When you neutralize both the time it takes to charge and the temperature drain of winter, the raw size of your battery stops mattering. You only need enough capacity to comfortably reach the next 6-minute stop. For the everyday commuter, this is incredibly practical. If plugging your car in takes the exact same amount of time as stepping inside to grab a coffee, lugging around a heavy 600-mile battery every day makes zero sense. We can finally shrink the battery pack. Cutting hundreds of kilograms off the chassis instantly improves the car's handling. It lowers the manufacturing cost, and it frees up physical space inside the cabin for passengers. But there are always exceptions. Commercial fleets and cross-country drivers still require uninterrupted distance, and they need it without turning the vehicle into a heavyweight tank. That is where the Keelan condensed battery comes in. Its underlying architecture wasn't even designed for cars originally. It was developed for CATL's electric aviation program, where excess weight literally prevents you from getting off the ground. By using aviation-grade titanium and removing flammable liquid electrolytes, they created a dense, fire-safe battery. It's capable of pushing a standard sedan up to 1,500 kilometers on a single charge, without a massive weight penalty. Whether stripping weight to make a commuter car nimble, or using aerospace materials for extreme range, tweaking the chemistry at the microscopic level dictates the physical geometry of the entire vehicle. But there is a catch. A hyper-advanced battery does you no good if the highway plugs can't deliver the power. To solve that, CATL is building the stations themselves. They are rolling out a unified infrastructure network that houses high-power superchargers and automated Choco-swap battery replacement bays under a single roof. This gives drivers a choice based on their exact schedule. If you are in an immediate rush, an automated system swaps your empty battery for a full one. If you have time to stretch your legs, you simply plug into the 6-minute supercharger. From an infrastructure standpoint, it is incredibly efficient. Sharing compact electrical substations reduces power loss between the grid and the car, pushing the station's equipment utilization rate above 85%. We are looking at the final threshold of matching the gas station experience. The fear of running out of range is gone, and the frustration of waiting around to recharge is cured. The next automotive decade will not be dominated by whoever builds the heaviest car. It will belong to whoever engineers the smartest, fastest energy loop. When extreme fast charging perfectly aligns with the stations delivering the power, moving away from fossil fuels stops feeling like a chore. It becomes a highly convenient upgrade to how we live and move.